And we're back here to talk about vectors. It's raise with an attitude. It's raise, and we talk about the direction it's going in terms of x and y. And instead of using brackets, we use these funny looking angled things here to talk about the component of which way it's going. This is in the x direction. This is in the y direction. So it's 5, positive 5 is 5 units to the right, positive 3 is 3 units up. That's the vertical component, and the horizontal component, the x. So we can talk about array FG, vector, this is like an array, except it's not an arrow, it's half an arrow, and it stands for vector. Vector FG, that means it's starting at F and going through G, and it has the components of 5, 3, because it's going 5 units to the right and 3 units up. There's the initial point F, right here, the initial point, and the terminal point G. Wasn't that exciting? We had our lovely cleaning lady here came in and said hello, but we're back. Here we go. Next slide. So let's look at this. Name the vector. So this is vector LM. Starts at L, goes through M, and it has a component of, well, let's see, it goes to the left this much, and then up 3. So plus 3, and to the left 2, 4, 6, 7. So minus 7 to the left. So the component form is negative 7, 3. In the bottom one, this is vector NO. And it has a component. Oh, it doesn't move left or right, so 0 to the left or right, and it rises 2, 4, 6. Oh, runaway pen. We got it back here. Oh, we're back in business here. So we're 6. So let's look at the next example. So the vertices of triangle DEF are negative 2, 0 for D, negative 1, 3, and 2, negative 1. Translate DEF using the vector 2, negative 3. So they went 2 to the positive direction and negative 3 down. They used that as the vector to translate it, and they can do that for D, E, and F. They went 2 plus 2 and negative 3 down. They did 2 in the positive direction and negative 3 down, using that vector to translate. Another way to do translations. Ingrid hit a word problem. A golf ball from the tee towards the hole. After she hit the ball, it got as far as point Y. So it got to here, point Y. When a freak gust of wind blew it to the point X, Mr. Waterman, oh, I'm sure this happens to him when he plays golf, blew it to point X. Write the component for TY. So TY, well, it went to the right. Well, that's the component. It's 220 to the right. And how much did it go up? It went up 85. Oh, we don't use parentheses though for component form. We need our pen tool here. 85. There's the component form for TY. Write the component form for YX. So how much did it go? Well, let's use a different color here. How much did it go to the right and how much did it go down? Well, it's positive to the right, so it went from 220 to 240, so it only changed to plus 20. And how much did it go down? It went from 85 down to 50, so minus 35. Went down 35. So our component form is 20, negative 35. And write the component form for the vector that describes a straight line path for which would allow Mr. Waterman to get to point H from the point X. So he wants to go from, let's get this one in red, from X all the way up to the hole to get, well, that would be a hole in 2, I guess, huh? Because the wind blew it off course. So he's going from X value of 240 to 250, so he's going over plus 10. So 10 to the right, and then he's got to go up from 50 all the way to 120. So that must be 120 minus